Hey Pixels, it's Michael Haddon. 45 enhancements, 12 of which are now unstable. This new Kubernetes release is shaping up to be quite interesting. Now, you may be interested what's going on behind me. I am in a new location, so that's why I've had my little hiatus the past few months, but I'm hoping to be posting on a consistent schedule again. So today we'll be talking about the new Kubernetes version 1.28, and it has an interesting feature, sidecars. Now, that sounds weird because surely Kubernetes has had sidecars for years. In fact, whenever I explain this to someone, how Kubernetes works, the conversation naturally goes in the directions of sidecars and the benefits of sidecars. But always, someone will say, well, how does this technically work? And then you have to explain, well, it doesn't, because Kubernetes doesn't actually have a concept of sidecars. We just explain it as if it did, but it actually never did. But now we actually have sidecars. So I'll explain what that means later on in the video, because it is actually quite exciting, and finally Kubernetes has one of the main features we say it has. But first of all, let's go through the general updates in this release and get a gist for the cool new things which are available. The first one, just to be aware of, is normally you have to have your worker nodes and your master nodes within 2 versions of each other, but now with this release it can be 3. So hopefully this is something normal going forward with Kubernetes, because when it is 2, you have to update your cluster 2 times per year. But now it's 3, you can update your cluster once per year. So this is a nice new change just to allow yourself more breathing room when it comes to your update schedules. So we have a hypothetical security issue regarding containers. If someone was able to get access to your worker node, they could inject a malicious container into your node's local cache of containers. If they were able to do this and your container had the pull policy of if not present, then when your container would start a new pod, it would pull in this malicious container from your local cache. Now in the new update, it will check the container registry to make sure these 2 hash sums match. So improvements to indexed jobs. So indexed jobs are parallelized jobs which you partition. The reason why you partition the jobs is so you can understand the partition your job is in. So for example, you need to collect the data relevant to that partition of jobs. Additionally, let's say if one of your jobs fails, you do not need to run all of your jobs again. You only need to rerun that one partition. But there has been some glitches with partition jobs. For example, when one is entered the terminating state, Kubernetes will automatically spin up the new job. The problem with this is you could have 2 jobs running in parallel. This causes all sorts of issues regarding machine learning, but now you can change the pod replacement policy and tell Kubernetes to not start the new pod until your current one has died. Additionally, there's a new retry back off limit which you can now configure to properly control when you want your new job to start. Now, one of my favorite things to talk about is the common expression language. I've been really looking forward to this becoming stable, but now we've hit beta. So it'll be exciting to see this develop further. The common expression language, just to remind you, is the Kubernetes-native replacement for Open Policy Agent and Kyverno. Basically, you can define policy as a code to control and restrict what certain agents can do inside of your cluster. The reason why this is important is it helps you lock down your system. For example, Kubescape has now posted on their GitHub a collection of example configurations for CEL, Common Expression Language, including 2 examples here, one for ensuring there's no privileged containers and disallowing exec into your containers. Additionally, that you can now integrate the CEL into your custom resources, which is quite exciting. And we have updates to the Gateway API. The Gateway API is the new version of the ingress controller. It's not meant to replace the ingress controller. That still exists. That's the simple implementation that just routes based on a path. But now we have the powerful Gateway API for complex operations. For example, being able to do canary deployments, blue-green deployments, route traffic based on metadata, and all sorts of complicated routing concepts. Traditionally, the Gateway API focuses on north-south networking, which is, if you imagine a data center, that's traffic coming into the data center and leaving the data center. Now, in the new release, the Gateway API fully supports west-east networking, which is, if you can imagine, the networking inside of a data center. So now, I have this example here. We can say we have a service inside of Kubernetes. We can tell it that if the connection has certain headers for its metadata, it will instead route traffic from this service here to demo app v1, which is quite exciting because now we can have the advanced networking inside of the cluster. This will completely change the way we configure service meshes, because basically the Gateway API will become the configuration language for service meshes. This is also exciting because previously when I've worked with service meshes, you invest fully into one service mesh, and then when you want to change to another service mesh for whatever reason, you realize, oh, I've got to redo all of these different configurations. But now, if we have a central language, a central interface for all networking, north, south, east, west, then suddenly we can change the underlying service mesh at will, which is quite exciting, just to be able to play around with what's best for your client. Right, now, I know this sounds ridiculous, but only now has Sidecars actually been added into Kubernetes as a feature. For years, we've been talking about Sidecars as a fundamental concept to Kubernetes, but there never was the link technically. For example, let's say we start our main container and it's our motorbike, so to speak, and it's driving down the road. It can go like 10 miles down the road before our sidecar is even attached to it, which means for those 10 miles it's spitting out all these errors into our Ops Genie, our PagerDuty, all these problems, making our canary deployments break, completely confusing us with what's going on, because there was no actual tie that the motorbike would wait for a sidecar to start. Now, we'll have all these like weird hacks we had in the past to try and fake this, or to try and temporarily wait until the sidecar was ready. But now it's actually part of Kubernetes. The implementation is a bit weird. It's not called a sidecar. It's actually an init container that you can now specify, and if I check my notes, you can now specify the restart policy to be always, which to me is a weird concept because that doesn't actually imply to me it's a sidecar. But the logic is this. It's an init container, so it will get ready before your main application, right? Restart always, so if it dies, it will keep recreating itself. So it's always going to stay alongside the life cycle of your motorbike, which is what you want from a sidecar. Now, when your main application dies, either because it's been terminated or it naturally ended from finishing its process, Kubernetes will wait until your main application is finished, and then it will send a graceful kill to the sidecar to make sure the sidecar has had time to finish any sort of network events or logging that it wishes to complete. And now suddenly we have sidecars. You could think of them as never-ending init containers, but is it a bit late? The main use of the sidecar is the service mesh. Now, I'm sure anyone who's run service meshes before and gone to Grafana at any point will realize just how much these containers are consuming of your resources. And as soon you or your manager does a calculation of costs, you have a little heart attack, knowing your service mesh is actually costing you this much money to run. Now, obviously, the observability is nice and useful, and security, MTLS, they're all great things, don't get me wrong. But it is a lot of resources, and for smaller clients, that's just absolutely ridiculous. And now we're starting to see the trend away from these containerized service meshes towards things like eBPF. So we're still using service meshes, but we're moving away from the containerized sidecar methodology. And so it's a bit weird that now, as soon as we start moving away from using sidecars as much, that's when it finally gets implemented into Kubernetes. However, I'm sure regardless of what happens, sidecars are always going to be a fundamental concept to Kubernetes, because it's always nice to be able to extend the functionality of your main application for things like logging, connecting to various service proxies, who knows. And so I'm sure this is going to be a feature which everyone is just going to use as is. But I'm going to be excited to hear your opinions and your thoughts down in the comments. Anyway, I hope you guys had a lovely time, and I hope you thought this was really interesting as I did. Thank you so much for watching, and I hope you guys have a lovely day. Cheers.